So the first one is our zero exponent property, which says anytime we raise anything to the zero power, we get just one. We looked at that a little bit when we did the probability questions recently, when it was like 4C4, and then we got something to the zero power. So you can see some examples. Your negative exponent rule, you cannot leave negative exponents in your final answer. That's not simplified. So negative exponents just move to their opposite location, usually to the denominator, and then they become positive. So you can see x to the negative 2 power would become 1 over x to the positive 2. Now remember, side note here, if it were to start out in the denominator, 2 over x to the negative 2 power, you would then move it actually to its opposite location in the numerator, and then it would become positive. So this would be 2x to the positive 2 power, technically over 1 if you want to. You don't need the 1. But it's just going to switch locations from the denominator to the numerator. The product rule is that when you multiply things that have the same base, you add the exponents. So here you can see x squared times x to the 4th gets you x to the 6th. A lot of times when you don't use these properties for a while, you forget them. If you forget them, you can actually expand. X squared is x times x to the 4th is x times x 4 times. And then if you count up how many you have, you can figure out what the rule is to add. Because some students forget, is it adding or is it multiplying? And they get confused. So if you forget the property, you can discover it just by expanding it. Power rule is when you multiply. When you have a power raised to a power, we multiply those two numbers together. And our quotient rule, when we are dividing, they have to have the same base though. That is important. We would subtract the exponents a minus b. So for example, x to the 5th divided by x cubed, we subtract those and get x squared. Now this one is actually not done. 2 to the 3rd over 2 to the 4th, we subtract and get 2 to the negative 1. We would then have to change this to be 1 over 2 to the positive 1, which then is just 1/2. So I just have a mixture of problems that I put on here. Some of them are easy, some of them are harder, and they're going to be all kind of mixed up. Your homework, you're going to have some hard ones on there. Remember the zero power rule though, that anything that's 0 power is 1. So if you see something complex and it's all raised to the 0 power, the answer will just be 1. I think there's one on the homework as well. Alright, so simplify. Your answer should contain only positive exponents. So when you have outside numbers, you are going to multiply those just like you normally would. 2 times 2 is 4. And then we will perform our exponent properties. We are multiplying using the product rule. That means we add the exponents. 2 plus 3 gets me the 5th. Now in the next one we don't have any outside numbers, so we'll just leave it 2. This is technically a 1, I guess. And we would add these exponents. 4 plus negative 3 will get me m to the 1st, or just m. And we're adding those exponents. Okay, now in the next one we start having different variables. So you do have to use only the ones that have the same base. So first of all, 4 times 3 is 12. Now we'll do the a's, a to the 3rd and a to the negative 4th. I would add them first before you start moving the negatives, as a suggestion. But so 3 plus negative 4 would be a negative 1. So we'll have a to the negative 1. And then b squared times b to the negative 3rd. We add those again and we'll get b to the negative 1. Last thing we have to do is anytime we have negative exponents, okay, we have to move them to the denominator. Once they get down there, they become positive. So 12 would stay up top because 12 does not have a negative exponent. A does and B does, so those would go to the denominator, technically positive 1 power, but you don't need to write them first. Same thing, use your like terms. We have x's, 2 and 3, add those, we get 5th. Y's, negative 4 plus 2, negative 2. And then move that to the denominator. So x to the 5th would stay upstairs, but y squared would move to our denominator and become positive. Now, when you have the power rule, you have options how you want to do these. You can distribute the exponent if you want. Make it 2 to the negative 1st and b to the negative 4th because you would multiply those. But usually if I see a quantity being raised to a negative exponent, I move it first So I would actually take this whole thing and move it down to the denominator. Since there's nothing in the numerator, you'll just put a 1 placeholder to keep something in the numerator. And then this would become 2b to the 4th all to the positive first power. Anything to the first power is just itself. So that would just be 1 over 2b to the 4th. The next one, we don't have any negatives outside, so I would actually distribute using our power rule, because you have to square each of those terms. So remember, the power rule tells us that we multiply the exponents together. So 2 times 2 would get me x to the 4th. Negative 1 times 2 would get me y to the negative 2nd. And then I would move my negative exponents. X to the 4th is not a negative exponent, so it does not move. It stays upstairs. The negative 2 will go to the denominator and become positive. So you guys can try the next two. And you can tell what they got for 20. Jade?
1 over 9 squared.
Good. Again, I would probably move that to the denominator first, make it a positive, then distribute my exponent and get 9. If you'd like, you can distribute it and make it 3 to the negative 2, m to the negative 2, and then move them. But usually if it's parentheses like that, it's a little easier. Okay. Now on the back, just another big mixture of problems. You can see some of them have multiple variables. And we do have some division back here. We didn't do the division rule yet. So the 4 and the 3 are not divisible. So they're going to stay exactly where they're at and not get reduced. If it were, let's say, 12 thirds, then we would want to reduce 12 thirds to be 4 over 1. And then you're going to use any like terms and use your subtraction rule. So 4 minus 2 is 2. Since that's a positive, it'll go in the numerator. So m to the 2nd power. Again, when you're dividing, the quotient rule says to subtract the exponents. So 3 minus 2 is n to the 1st, which is a positive 1, so it technically will go in the numerator. And 3 minus 4 is a negative 1, so your options are you can either put p to the negative 1 up top and then move it, or you can just mentally move it and make it a positive 1. So it's up to you whether you want to just move it mentally or if you want to actually put it here and then move it down. So our final answer should be 4m squared n over 3p. Okay, the next one, anything with a 0 power is just 1. So you can actually just get rid of those. And here is where I see a lot of students make mistakes. Right here. The rule is to subtract the exponents. So this would be 3 minus a negative 4, which will become a positive, which will then get us 7. So this will be x to the 7. Now if you prefer, you can take the negative, use the negative exponent rule, which is to move it to the numerator. And then you would have x to the 4th times x cubed, which you add the exponents to get x to the 7th. So there's multiple ways to do these with the properties. And then the next two, these just went away, became 1. So the negative 1 will move down to the denominator, and the negative 1 for the z. So we'll have y z. So 3x to the 7th over y z. See, the numbers are all shuffled around because I pulled them from 2 different worksheets. Easy and hard. The next one we'd want to first, well, since these are both x's, you might want to combine those first. It doesn't matter. You can distribute first or you can combine. These are both x's though. So if we're multiplying, that means we add the exponents. So negative 2 plus a negative 3 will get me a negative 5. All raised to the 4th power. And then power to a power, we multiply those to get negative 20. And And then at the end of the problem, the negative needs to move to the denominator, so we'll put a 1 in the numerator, 1 over x to the 20th. If you did it the other way, you would get x to the negative 8, x to the negative 12. You would still get x to the negative 20 and 1 over. So it doesn't matter which way you go. Why don't you guys try the rest? And then we'll get 5 of each of the board.